Hi, Tyler here from Vortic Watch Company, and today we're talking about what is a lathe. In its most basic form, a lathe as opposed to a mill, the difference is on a lathe you spin the material, not the tool. So now the material is spinning and we come in with a stationary tool that shaves material off. Whereas on a mill, we have a spinning tool and a stationary part that we're shaving material off. This is our first CNC lathe. It's a HAAS CL-1, the smallest lathe that they make. And this is a very straightforward, basic machine. This has just 2 axes. So the table here can move in X, like this, or in Z, like that. And that's all the motion that this machine has. The material sits in the spindle here, and this spindle spins. So the basic form of a lathe, like I said, is material spinning and stationary tools coming in and shaving material away as the part is spinning. An additional feature on this machine is live tooling, and it gets a little bit confusing because we can mill on a lathe. Live tooling is, for example, these tools here and this air tool here. So these have a spinning tool that can come in and shave material off of our part, very similarly to a mill. So you can do milling on a lathe, but it doesn't change the fact that this is a lathe. Yeah, so this machine has a turret style tool changer, and each of these tools gets presented to the part when this table spins. So if we close this door, we can watch it move. Depending on which feature of the part that we're working on, we can turn this table around and present different tools to the part. All right, now I'm standing in front of our ST20Y from Haas. This machine is a little bit fancier. As opposed to the CL1, the 2-axis lathe that we have, this is a 3-axis lathe. So the reason, it's still a lathe. We still have our material in the spindle. This spindle spins the material, and we have our cutting tools that will come in and shave material away. This also has a turret style tool changer. It's just oriented a little bit different. What makes this a 3-axis lathe is that the turret has 3 axes. So we can move in X, X, Y, and Z. And the reason that that's important is the things that we can make are totally different with 3-axis as opposed to 2-axis. Just like the CL1, we have milling tools in this machine as well. We have live tooling. So some of these spindles will spin and can mill just like a milling machine. But when we have 3-axis, there are certain features of parts that are only capable of being produced on a 3-axis lathe as opposed to a 2-axis. So it's a lot more flexible. So another thing that makes this machine different from the CL1 is this is a sub-spindle lathe. So it technically has 2 spindles. And why that's important is on a lathe, oftentimes we're cutting the part and then we cut the part off. And the part either drops off or has a secondary operation. But when we cut it off, it'll have a small nib or leftover material that we don't necessarily want there. On the CL1, we can only do operations on the front side of the part. So we're only finishing one side of the part, and they're going to need to go back into the lathe again to have a second operation done, or into one of the mills or a different secondary operation to finish the part. On this machine, we can start the part on the main spindle, come in with this sub-spindle, grab onto the part while they're both spinning, cut that part off, retract the sub-spindle, and actually do work on the back side of the part. So when the sub-spindle is done with the part, it'll eject it into a parts catcher, and we have a fully finished part. So that's really the big difference between a regular lathe and a sub-spindle lathe. A sub-spindle lathe has 2 spindles and can produce fully finished parts without secondary operations. Something that makes lathes so productive is how easy it is to set up automation. On a mill, if you want another piece of material inside of it, you have to put it in somehow, whether that's a robot or a human. There's different ways of doing it. On a lathe, we can put a full bar of material in the machine, so it'll continue cutting off individual parts and pulling more material out, cutting the next part, cutting that off, catching it in a parts catcher, and then pulling that bar forward so we can cut another part. And it's fairly common in the world of lathes to have a bar feeder. And what this bar feeder does is that we can have multiple bars in this thing, and it will load the bar into the machine automatically. So especially for us, when we're making very tiny parts, this I believe is a 4-foot bar feeder. Out of a 4-foot piece of material, we can make sometimes 100 parts. So this will keep loading bars into the machine, each bar making somewhere around 100 parts, and we can let this machine continue running. All right, now I'm standing in front of our newest lathe. This is a Swiss turning machine. Also has a bar feeder on it. This is quite a bit fancier than the Haas bar feeder. First of all, it's a 12-foot bar feeder, but the concept is the same. We load bars into the front here, and this machine will keep loading bars into the machine as the machine is making parts and cutting them off. What makes this a lot more fancier is on a Swiss machine, generally speaking, the spindle is a lot faster. The bar feeders that we have on our CL1 and our ST20Y limit the speed that we can turn our material at because it'll cause too much vibration because everything's not quite perfect enough. On this machine, everything is about as perfect as we know how to get it. And we will spin material, a 12-foot bar of material, at up to 10,000 RPMs, which is important because generally speaking, the smaller the part, the faster you need to spin it in order to get the proper cutting conditions. So still a bar feeder, still a lathe, just a lot fancier, a lot faster. So again, we're still working on a lathe here. We are still spinning the material, even though this is a Swiss turning machine, a different style of lathe. We're still spinning the material and shaving away as we go. What makes a Swiss turning center different than a turret style lathe, which we just showed you 2 of, is that a Swiss machine doesn't have turrets. It has sets of gang tools, so just tools lined up. It doesn't spin the tools, and the tools only move in X and Y. The material is actually the Z axis on this machine. And the reason for that is that it's always as close as possible to the spindle, so it has the highest level of rigidity that we can get. The other thing that makes a Swiss turning center different than those turret machines is we still have a sub-spindle. The sub-spindle is a lot nicer than the sub-spindle that we have on the ST20Y, but we also have 2 sets of gang tooling on this machine. So we can work, so just like on the ST20Y, we'll transfer that part from the main spindle to the sub-spindle to work on the back side to make sure that we're making a fully finished part. But this machine can work on the main spindle and the sub-spindle at the same time. So we're basically cutting our cycle times in half because we're doing 2 operations at the same time, whereas opposed to those turret machines where we're either working on the main or we're working on the sub-spindle. The material actually feeds in and out of the main spindle instead of these tools moving forward and backwards. So like this is the first set of gang tooling, and this is the second set of gang tooling. And just like on those other lathes, these have live tools, spinning tools that can do milling just like a mill. And they also have stick tools, round tool holders, but these gang tools don't move in the Z-axis. The sub-spindle and the main spindle actually move in the Z-axis.
And then the material as well.
Yeah, it's a little confusing because it can do both.
Okay.
So that this actually full spindle can move, and it can also stay in the same place and feed the material very accurately. It's got 2 different modes, depending on what you're doing.
I see.
A classic Swiss setup is feeding the material in the Z. Yeah, so this machine has a real fancy parts catcher, another upgrade from those other machines. This little compartment will flip up in front of the sub-spindle. The sub-spindle will eject the part into here, and then this thing comes around and dumps the part onto this conveyor. It really is, and the conveyor comes along to the back of the machine and spits out your little parts right here. And the reason that this parts catcher is so different from the one on the ST and on the CL is it's more optimized for small parts. Everything on the parts catcher over there is big, and honestly, small parts, if we didn't put screens or anything, they'd fall right through the cracks. This machine's totally optimized for small parts. It's got a tiny little rubber conveyor. It's not going to scratch them. This is the last machine on our lathe tour. This is a manual lathe from Shoreline in California. This is one of the first 2 machines that we bought along with our manual mill, something I used to make our first cases. And again, the concept is a spinning part, spinning material, and stationary tools. This is not a CNC lathe, this is a manual lathe, meaning that I need to come in here and spin these hand wheels in order to make the tool move. But it's just a 2-axis lathe, X and Z. And then our spindle spins. And lathes come in all different shapes and sizes, anywhere from as small as this to as large as this whole room. Some of the fancier lathes they call mill turn centers. If you ever hear of a mill turn machine, they're actually somewhere between a lathe and a mill. They'll have a milling spindle that can come in just like the mills that we have that can change tools and do everything that those machines have, but they can also spin the material, and they can also have a sub-spindle. So they can start parts on the main spindle, come in with a milling head, mill, come in with a turning turret and turn it, and then transfer it to the sub-spindle, mill with a head, and then come in with a turret and turn it more and finish parts. Yeah, again, just they come in all shapes and sizes, but for it to be a lathe, it has spinning material, stationary tools that come in and shave the material off.